Okay, good morning or good afternoon to all of you. Last lecture, we have seen the three asymptotic notations. First, big OH. There are two functions, f of n and g of n, such that the relation between these two functions, f of n is equal to big O of g of n, there exist if and only if there exist two constants. C is always positive constant and n0 is always greater than equal to 1, and this equation can be also written as f of n is less than equal to c into g of n. Okay, this is in case of big OH notation. This is also known as upper bound notation. Then we have seen that these two functions f of n and g of n can be written in omega function as f of n is equal to omega of g of n if and only if there are two constants where c is always positive constant and n0 is greater than equal to 1, and relation these two functions can be written in the form as f of n is always greater than equal to c into g of n. It is also known as lower bound, and in case of theta we can write f of n is equal to theta of g of n, such that there are two types of constants, c1 and c2. All constants c1 and c2 always greater than 0, and another constant n0 is always greater than equal to 1. So c1 into g of n is less than equal to f of n is less than equal to c2 into g of n. So the function f of n lies between these two parts. The first part is big O, second part is theta, second part is omega, and this theta lies between these two parts. So this is known as the average bond. First is upper bond. In case of big O, then in case of omega, it is lower bond, and theta lies between these two, upper bound and lower bound, is known as average bond. Okay, we have seen these three asymptotic notation. Now we move towards the next point, the properties of asymptotic notation. The first property is if if f of n is if f of n is big OH of g of n, then a into f of n is also big OH of g of n. If f of n is equal to order or big OH of G of n, then any constant A into f of n is equal to big OH of G of n. We'll see one example. If f of n is equal to 2n square plus 5. If f of n is 2n square 5, then here big OH of, what is the value here in bracket? Hello? What is the value of G of n? We have seen the examples on big OH. Hello? We have seen or not? Hello? We have seen examples on big OH or not? आपण बिग OH वरची एक्झाम्पल बघितलेली आहेत की नाहीत? Okay, let us see another example. We have seen a previous example, f of n is equal to 2n plus 3. Then we should have to find c into g of n. What is the value of c into g of n? I want to express this example in this format. F of n is less than equal to c into g of n. So here you have given f of n is equal to 2n plus 3 less than equal to, what is the value? Here c into g of n. We have seen this example or not?
Five.
5. What is next? 5? Only 5
N.
or 5?
5n.
5n or 7n or
5n.
10n or 10n, 11n, whatever. Okay. Any constant we can take. Are you getting? Are you getting? Any constant greater than 5 we can take. Any constant greater than 5 we can take in this example. Okay. Then समज. Hello. Hello. तुम्हाला समजलंय?
Yes, sir.
Okay, here we have taken C of C into G of n as a 5n or greater than any constant, greater than 5, any constant we can take. Suppose 10n someone has taken, it is also right. 100n, it is also right. Okay, but C, what is the variable? So that is f of n. Instead of this, I can write f of n is equal to order of n, because C here variable n, here also variable n, and that's why here I can write f of n is equal to order of n. See in this property also, if f hello, hello, hello,
Yes, sir.
hello. Hello, hello.